Hi, I'm Ruth Duerr from the Ronan Institute, but in this talk I'm representing the ESIP Semantic Harmonization Cluster. The main contributors to the cluster are included as authors here. ESIP, or the Federation of Earth Science Information Partners, has a vision of being a leader in promoting the collection, stewardship, and reuse of earth science data, information, and knowledge in response to societal needs. Obviously, given the interdisciplinary nature of most problems these days, that includes making earth science data broadly interoperable. It is supported by NASA, NOAA, and USGS, and acts as a neutral space for folks from all over to get together to move things forward. And here are some examples of the organizational partners within ESIP. ESIP gets stuff done through collaboration areas, both committees and clusters. You can see the Semantic Harmonization Cluster on the list. Collaboration areas get stuff done by holding open telecons, creating outputs such as the data citation guidelines that have been broadly adopted, and maintaining resources needed by the broader community. With that introduction, I am here today to talk about the progress we're making in the Semantic Harmonization Cluster. So what are we trying to do? Well, we are trying to tackle the biggest interoperability challenge that data has. That is simply that language is fluid. Terminology changes over time, and the meaning of any term in use can vary widely between differing communities. Just think of all the meanings of a simple term like explorer. What do you think of? An automobile? The Internet Explorer? The first satellites launched by NASA? Magellan? Something else? All are valid, but each is only applicable in its own context. As a graphic example, a few years ago, the Global Cryosphere Watch hired me to take a look at the terms in the 27 glossaries they had compiled. Most of the terms had at least 2 definitions. This, despite the fact that these were all cryospheric scientists of some sort creating these glossaries. Here's an example of what I found. Many terms, like ablation, had multiple uses. In this case, as a process, a region or zone, or an amount of mass. The meaning might have changed over time in the literature and in the data. Where the term was thought to be applicable varied a lot. In general, it was a mess. In addition, the more disciplines that used a term, the more likely their definitions diverged. But keep that thought in your head while we diverge for a moment to take a look at the kinds of semantic resources that there are out in the wild. They range from the basically textual, like control vocabularies and glossaries, to the machine computable like ontologies, and then there's everything in between. While this graph is currently labeled with weaker semantics and stronger semantics, it could equally well be labeled with weak interoperability and strong interoperability. When we're talking about semantic harmonization, we're talking about all of these resources needing to be harmonized. Why? Well, imagine what would happen if each community created their semantic resources using their favorite definition of ablation. Say the process in one community and the zone in another. And now imagine what would happen later when those communities tried to reuse each other's data and systems. I don't know about you, but I think that trying to equate data about a process with data about a region might be somewhat problematic. It would be chaos, the Tower of Babel. Bad science everywhere. But enough about the problem. What has the cluster been doing about it? Well, the first thing was to harmonize semantic resources at the upper levels of the semantic ladder, based on previously harmonized resources from the lower end of the ladder. We used the work I'd done in harmonizing terminology from the GCW glossaries. The resources addressed included the suite ontology started by Rob Raskin and currently maintained by ESIP, and the environmental ontology which came out of the biomedical community and the OBO Foundry. As a result of that work and from the experiences in the team, a number of lessons learned were compiled and a set of practical recommendations developed. Yes, we're in the process of writing these up. These include the idea that semantic resources themselves must be fair, findable, accessible, interoperable, and reusable. The FAIR principles state that data and information about data must be fair, so by definition, semantic resources used to describe data must be fair. Doing that means that aligning resources will become easier and interoperability will be improved. Similarly, semantic resources need governance if they're to be widely adopted, maintained, and reused. And last but not least, stop reinventing the wheel. There seems to be the idea that if you're going to use semantics at all, you need to start from scratch and invent your own stuff. But that just proliferates the interoperability problem. Instead, reuse, extend, or revise the resources that are already out there. Established resources have processes for revision or extension. Take advantage of them. If there are problems, bring them to the attention of the wider community. Last but not least, the cluster is working on tooling. The Obo Foundry already has tools such as Robot to help set up and maintain an ontology repository, as well as to test its coherence. ESIP has been extending these with additional tools such as this spreadsheet template for adding terms to Envo. Any questions?